let's now continue and look at grouping. Now, the principle for grouping is quite simple. We're going to find the number of arrangements that can happen within each group, and then we are going to consider each group as an object that can be arranged. And we'll see there it says if no order of groups are given, and we're going to see what that means. Okay, so on a spice rack, we have 4 green spices, 3 blue spices, and 2 orange spices. So it asks, in how many ways can the spices be arranged on the spice rack? Okay, so for this, we have 4 plus 3 plus 2 unique things, and there are then 9 of them, right? So if we have these 9 things and there's no limitation on how we're supposed to order them, then the number of ways it can be arranged is going to be 9 factorial. Again, because the first position can be occupied by 9 things, then the second position by 8 things, and that goes on and on and on until we just have the one thing to choose from to put on at the end. Then it asks, in how many ways can the spices be arranged if blue comes first, then green, and then orange? Okay, so now we've been told that we have a certain grouping. So we first have blue, then we've got green, and then we've got the orange at the end. Okay, now the principle was we have to find out how many ways we can arrange things within the group. Now, we have 3 blue spices. So let's say it's vinegar, garlic, and salt, right? So we can either put the vinegar first, then the garlic, then the salt, or maybe the garlic and then the salt and the vinegar. And these are all ways in which those 3 things can be put together. So, because we have 3 things to arrange within the blue group, we can select how to place that blue group there in that first spot in 3 factorial ways. So there are 3 factorial arrangements within the blue group. And then for the green here, because there are 4 of these spices, those 4 green spices can be arranged in 4 factorial ways. Since there are 4 of them, and then the orange spices, because there are 2 of them, they can be arranged in 2 factorial ways. And then, because of the fundamental counting principle, the ways in which this blue, green, and orange thing can happen together, we just multiply this all together, right? So then the total number of arrangements is going to be 3 factorial times 4 factorial times 2 factorial. Now it says, in how many ways can the spices be arranged if all the spices of the same color must be together? All right, so I just want to check this again. It says, in how many ways can the spices be arranged if blue comes first, then green, and then orange? And now it just says, if all the spices of the same color must be together. Okay, so it's still telling us that we have to group, because blue has to be with blue, then green with green, and orange with orange. But it's now not saying that we have to first put the blue, then the green, and then the orange, right? So what we had was we had the blue, the green, and the orange, right? And the blue within that group, we had 3 factorial. Here within the group, we could have arranged it in 4 factorial ways, and then for the oranges, 2 factorial, right? But now, those groups themselves are objects that can be arranged on the spice rack, because we can either go green, blue, orange, or orange, blue, green, or whatever the case may be. So because these 3 groups themselves are now able to move, there's an additional 3 things that can be arranged, and we can then multiply by 3 factorial. So that 3 factorial that we're multiplying by, that represents the fact that the 3 groups can be arranged in 3 factorial different ways. And so the answer is now going to be 3 factorial times 4 factorial times 2 factorial times 3 factorial. And then finally it asks, in how many ways can the spices be arranged if only the green spices have to be together? So now what's happening is the green spices are a group, and in that group there are 4 factorial arrangements. But now we can go blue, orange, then all of the green spices, and then some of the rest, whatever the case may be. So this green spices, we can actually think of it as one object. Okay? So we can start with the green spices, then a blue, then an orange, then another blue, then another blue, then an orange, for example. Or we can put the greens in the middle and the blues and oranges can go wherever, right? So the blue spices we have 3 of and the orange spices we have 5. So we have 5 spices to arrange plus the group of green spices that can go anywhere on the rack. And so the total number of things that we can arrange are the 5 spices and the group of green spices, and so that's going to be 6 factorial arrangements. And so to find the total arrangements here, that's going to be 4 factorial times 6 factorial. I'd like you to now please pause the video and try these following grouping questions. Fantastic. So, we have the 10 students and they're sitting in a row to watch the Tour de France. There are 5 Ineos supporters, 3 Movistar supporters, and 2 Cofidis supporters. So, what's the probability that all the Ineos supporters sit together? So now we're talking about probability, and we know for that we have to go and take the number of outcomes for the event divided by the total possible number of outcomes. Now here, the total number of possible outcomes is the total number of ways that 10 people can be arranged to sit somewhere. And that's going to be 10 factorial because again, whoever sits in position 1 can't sit in position 2, etc. So we've got to find the probability that all the Ineos supporters sit together. So if we call this A, the number of ways in which the Ineos supporters can sit together is the following. So because they're sitting together, they are now a group. And because there's 5 of them in the group, that group can have 5 factorial arrangements within them. Then we take a step back and consider that group of Ineos supporters to be just one of the objects that can be arranged. So we can have a Cofidis supporter, then the Ineos group, and then another Cofidis, and maybe then the rest of the Movistars. Or we can put the Ineos at the end, or however it goes. So now we've got the other 5 people left, plus the group of Ineos supporters. So there are 6 things that we can arrange, and so the number of ways... I've gone too far, that this can happen is going to be 5 factorial times 6 factorial. So then the probability of these guys sitting together is going to be that 5 factorial times 6 factorial over the 10 factorial. Then it says, what is the probability that all the supporters of each team sits together? So now for this event here, basically we're saying that we're grouping it and that we've got 3 groups. So first, we're going to find out how many arrangements there are in each of the groups. So the 5 Ineos supporters can sit together in 5 factorial ways. The Movistar supporters can sit together in 3 factorial ways. And then the Cofidis supporters can sit together in 2 factorial ways. But now, there are 3 groups. And we can either go Ineos, Movistar, Cofidis, or Cofidis, Ineos, Movistar, etc., etc. So we've got 3 things that we can arrange, those 3 groups, and so we have to go and multiply by 3 factorial still. So then this probability is going to be the 5 factorial times 3 factorial times 2 factorial times 3 factorial divided by the sample space, which is the 10 factorial. And then we've got to find the probability that the Movistar supporters do not sit together. Now again, it's way easier to find the number of ways in which they can sit together than it is to find the number of ways in which they do not sit together. So the probability of C, them not sitting together, is going to be 1 minus the probability of C's complement, which is then the probability of them sitting together. So we're going to go 1 minus, and then in the denominator we still have the 10 factorial. And now we're going to ask ourselves, in how many ways can they sit together? So within the group, there are 3 factorial arrangements. So within the group, there are 3 factorial ways in which they can sit. And then the group becomes one of the objects that can be arranged with all of the other people, the other 7 people who are sitting there. So we have 7 people to arrange, plus the group that has to go somewhere. So we have 8 things to arrange. So this is going to be 3 factorial times 8 factorial. And then that 1 minus the 3 factorial times 8 factorial over 10 factorial is going to be the probability that the Mosby star supporters do not sit together.